Okay, well, hello. We're gonna go ahead and get started on chapter five. Uh, chapter five, we're gonna kind of do a little bit different. We're gonna do a little bit more demo here, and we're first gonna talk about the while loop and some different things. Specifically, we are going to talk about the while loop in the form of input validation because input validation is so important. And the example we have right here from your PowerPoint, we're gonna just grab this guy and make it work. And then what we'll do is, after we get done with talking about while loop, we're going to kind of transition into talking about files and file output. We're going to build a file output class where we then discuss a for loop and how a for loop kind of compares with the while loop. And then we will build another class to read information from a file. So we'll build a class with the for loop to output information to a file. And then we'll build another class with a while loop that inputs information from the file. So let's go ahead and begin by just looking at a while loop, and we will take this stuff and just comment some things out as we examine kind of the three characteristics of a while loop. Please ignore, I've got some border collies around me, so they may whine every now and then, and I may have to take a break to put them out. And then, of course, Alexa always has to have an intrusion into our day. Maisie, quit it. So let's go ahead and begin with a discussion on while loops. And we're going to pare this one down quite a bit just for our initial discussion. I'm going to go ahead and just paste that in there and make it pretty. Then we'll kind of get rid of some of this stuff and of course, then demo it. So the form of a while loop has like three parts to it. A while loop, is essentially a looping control structure. And now we talked about control structures with if statements, and kind of how control structures behave, and the fact that they're only looking at a true or false. That's all they care about. They don't care about anything else. They just care about whether the expression comes back as a true or false. And those expressions can be either mixed expressions with mathematics in it, like plus, times, divide, but they all usually contain what we call a relational operator. And then, of course, we talked about the logical ands and ors. So those all can work within a while loop. But we're going to talk about while loop within its most simplest form. And before we begin, I'm going to just kind of comment most of this stuff out. And let's just talk about a really simple version of a while loop before we begin on anything else. And once I get this code in, we will begin with that discussion. And what I'm going to do is I'm going to go ahead and just create a number here. That'll be just a simple integer number. And let's assign it to 0 as a beginning. And then the while loop will say, hey, while number is less than 1 or number is greater than 100. So essentially, this while loop will continue to operate as long as number is less than 1. But we're going to simplify this a little bit. We're going to come back to that. And let's just talk about number and the three characteristics of a loop. And let's say while number is less than 10. Okay, so it looks like I've got to pause the video and come back here in a little bit. All right, well, the border collies are outside, so we won't have those interruptions. Let's go ahead and continue with the three parts of a while loop. The loop has to have something to kind of keep control of it to decide whether or not it should continue to to repeat, and that's what loops do. They just repeat a set of instructions, and with that and other control structures, you can have some complex behavior. And it's also what we would kind of refer to as automation. And automation is kind of a pretty big idea out in the computer science world, all the way from robotics to artificial intelligence to text to speech, speech to text, all this stuff. And of course, Alexa is automatically always listening, and that's done through a loop, repeating over and over, did you say something? Did you say something? So, Alexa, Siri, all those other, speech to text or speech, they all work on that repetition idea. And then also repetition is kind of the brains of a computer. It's the only thing that will allow it to do things complex and also have any kind of intelligence whatsoever. It's all done through repetition, a lot of repetition. Often you don't realize how much is actually going behind the scenes until you actually start having to code it and you realize how much work it really is. So that the three parts are, the first part is we have to have some kind of number that terminates the loop. So this number is our loop terminator, and then we have to have a start. Where does the loop start? Well, we're using the number to control the loop, so we're going to start the number at 0. Then we have to have the second part of a loop is what is the expression that terminates the loop. In this case, we're saying while number is less than 10. So what happens is we're always looking at number, and number says it's less than 10. Is number less than 10? Well, number is 0, so this will always say is true. So that's a 1. Remember, that's my version of true. And then a 0, of course, is false. So a lot of games, we would have it as while 1 because the user would stop the game. So with repetition, you want to have some time where that loop becomes a 0. And in this expression, if we were to set number to 10, now it's no longer less than 10. So number less than 10, that's going to come back as false. While looks at the 0 and it stops repetition. It no longer repeats. So we have the first part, which is some kind of value, or sentinel is not really the right word, but a value, an iterator is the correct word. Some kind of iterator. We also will call these accumulators. And like for the pennies for pay program, accumulators can be used, and they accumulate values through the loop. It means that the numbers get larger. And then a way to stop the loop. And then, of course, you have the accumulation. You need some kind of update to happen in the loop. In this case, we're going to say number plus plus. Now, number plus plus, all it does is add 1 to number. It's a shorthand for number is equal to number plus 1, which also can be shorthand for number plus equals 1. Now, these are all just shorthand for the same thing because it happens so much. Accumulators is such a huge thing that we're always typing them out. So we want, so they've built the tools to make it, because we're always typing them out, make it so that we don't have to type as much, and because they're always used. So we have our three parts: our accumulator, our loop termination, and then our loop. Our loop accumulation or iteration or update. And then basically here's what we would want to do is we want to kind of track what's going on. And we can do this by, just looking at the value number. And what we'll do is we'll just output number with, and this is a print line, which is good because we'll have a new line at the end of each one. So we'll just say print number. And then a new line character will automatically put in there because it's the print line command. All right, now I'm going to go ahead and hit play, and we're going to run this. And number is going to start at Oh, well, nothing's going to happen because I set number at 10 and it's no longer less than 10, so it becomes us false. So the loop is just ignored and doesn't run. So now let's go ahead and run it, and we will see the values 0 through 9 here that are printed out. 0 through 9. So let's reduce this down to just 3, and let's go ahead and do a walkthrough on the debugger. So I'm going to set our breakpoint for, let's just set it for, now let's set it for right here. That'll be fine. I'm going to make sure I run the debug project so that I can see kind of what's happening. We have number is already 0. We've stopped it. Is number less than 3? Well, number is less than 3, so this comes back as a 1 or a true. And then that means go ahead and run the lines of code that are in the scope of the while loop. That is your starting bracket and your closing bracket. Sometimes I call them parens. Sometimes I call them squigglies. Or braces. I think braces is the proper term. I don't know why I call them parens. It just sometimes happens. It may be, you can look into it if you want. But so the first thing to do is we output that 0. So the 0 comes out, and you can see down here we got the 0. Then number is updated, and then it continues on. It checks number again, since number now is 1, and 1 is still less than 3. So then it outputs the 1, and then number is updated again. Number becomes 2, and we can add a watch on this. New watch. And we can keep an eye on what number is. Some of these are from when we, let's just, I don't want to get too messing around too much here. Number is 2 over here. So that's still true. So it evaluates what's inside of the scope of the while loop. It outputs the 2, but here's where things change. Now all of a sudden number updates to 3, and we're saying, hey, while, and since number holds the value 3, is 3 less than 3? No. So that comes back as false. So no longer is what we're having happen. We've outputted 0, 1, 2, 3 numbers, and you notice how I'm doing this 0 based. You always want your loops 0 based. And there's a reason for it, because you can have fence post errors. So you really never want to start a loop at 1, because if you start loops at 1, immediately when somebody sees your code, they know that you don't know what you're doing. So really always start at 0. So 0 is actually the number 1. In programming and in science, mathematics, they don't really look at 0 very much, but it's implied. Just keep that in mind. We have 3 numbers from 0 to 2. Now our runtime is going to skip over and not run what's in here. So you notice that we have no output, and then the program is done running. Now, one of the main things that can happen here that causes a big problem is, what if we forget something like, let's forget. First off, let's stop our debugging. I think we're good. Let's just remove that. Let's stop our number plus plus. Okay, so we're going to comment that out. Now here's the problem with this, is because number will never ever be greater than 3. So the loop is just going to continue to run. Now some IDEs and languages can detect it and give you an error on this, and we call it a runaway loop. If we go ahead and run this, we will probably start into a runaway loop, and it may detect it, but no, it doesn't. So that's good, actually. So it's just continuing to output these zeros. That's all it's doing. And this is actually running over and over right now, and you see it's just kind of thinking over, because we have a runaway loop. It's not, the program is not ending. So therefore we have to manually stop it. That would be a Control-C if you're doing this in DOS command line mode. Up here, since we have it run away, we can just hit that stop button to force the quit of the program, since essentially the program never gets out of the while loop. It just continues into it, printing zeros over and over and over and over again. And that's our runaway loop. So those are the 3 characteristics of looping. And, I'm not going to discuss the do while loop. You guys can read about that. It's very similar to the while loop. One is a pre-check, one is a post-check as far as the relational expression, whether it's true or false. The main loop that we will be discussing next is the one loop that you should use most of all. Essentially, you should not be using a while loop unless it is required for something like this instance where we are asking for valid input. Well, the user can be really silly and not really know what is expected and continue to put in incorrect input. And so that's the only place that we would want to use a while or a do while, is when we want to do like validation, or when we have code that we want the user, we want it to automatically always be looking, always be listening until some action by the user stops the loop. Any other loop that you should be doing is a for loop, and it should start at 0 always. So let's go ahead and do the input validation, because we're actually going to use this as we progress in code coming up. But you know what? We're going to be building a currency generation. So let's make this a float. And let's say that we can enter in a number that this one accepts only a number. It will continue to ask for a number until you enter one that is between 1 and 100, or 1 and 99 or something like that. But in the range of, as long as it's less than 1 and greater than 100, it's invalid input. So the loop runs again to get more input. In this case, what we're going to do is we're going to be asking the user to enter in currency. And the only time it can be false is if that currency is less than 0. And since we're doing currency, let's just do 0.0. So if that, you know what? You can input a negative currency. That would be a debt. So yeah, I see that too many times on my bank account. But for this purpose, let's just call it good. Now here's the thing that we're going to be changing here. So you see the keyboard, it's expecting an integer for the input of number. Let's make that next. I believe it's going to be float. Would that work? I may need to look into that here shortly. And maybe next double or something like that. Getting a double as a keyboard. Yeah, okay. I'm going to have to pause and come back so I can look that up. And then what we're going to do is we're going to test our input and our input validation, and make sure that we only are able to enter a number that is greater than 0. So this will be enter a number greater than 0. That would be our validation. And then we would say, go to the keyboard, get the next number, input. And of course, I'm going to look at exactly what that particular line of code is. And I will be right back. We will continue on. Okay, yeah, well, it was a simple one. It was, I didn't put the keyboard scanner utility include. So I'm going to import that up above here. Let's see, import Java utility scanner. Okay, now it should hopefully take it. Maybe. Oh, duh. Semicolon. Okay. And I think that should be after the package, most likely. Yeah, okay. There we go. Now, we might have a different problem. Yes, we do. I didn't instantiate keyboard. And up here, what we'll do is we'll instantiate keyboard with a scanner. Okay. I think that is going to be first system input. And then we've got it. Okay. Now this actually can be written a lot better with a do while. And that's because you notice here that we've got to get the number first, then look at the loop or run the validation. And then if it's invalid, we get the number again after showing an error. A do while will allow you to not have to worry about doing it this place first. And you know what? That's actually kind of a good reason why we can cover do while real quick. So let's go ahead and just run through this. And then we're going to take probably a bigger break because I think this video is going to run into like an hour and a half. And then we'll get into the file output stuff with a for loop. So this will be good for talking about do whiles as well. So let's go ahead and just kind of set a breakpoint and run this and see the behavior. And what I'm going to do is it's going to ask for a number, and I'm going to do a step over here. Then I'm going to enter in the number. It's not really asking it on the screen, which is okay. But I'm going to do a negative 2.0. And negative 2.0, if we look at number, we should look at our variables and numbers here. And we see it's a negative 2.0, so that worked. So then I'm going to do a step over. And it's going to say, hey, error. I'll go back to output here. That number is invalid. Enter in a number greater than that. So I'm going to say next here again, and now I'm going to type in negative, oh, whoops, okay, I should put it over here. Negative 3.0, hit enter, and it's going to go and it's looking at number, it's negative 3.0, nope, you didn't enter a number that is greater than 0.0. So now I'm going to enter a number that is $2. And now it says, hey, is number $2? We look at variables. It's 2.0, $2. We'll have to do an output of currency on that. There's a special formatter for it, but let's not deal with that right now. I'm going to step out, and then, okay, the validation is done. Number is $2 or 2.0. And we have broken out of the loop that's continuing to validate that. And that's how a lot of ways how input validation works, is because you got to continue to ask for that number. Now, one thing that I would like to do is modify this so that it works a little bit different. We shouldn't be doing that. We shouldn't have to do that. So let's just do a do while here instead. So do while, it's separated. It's the same thing as a while, but what it does is it allows the body of the loop to run first. And sometimes there's some special syntax, like a semicolon needs to be added at the end. It looks like Java is definitely that way. And so what we'll do is we'll prompt the user to enter, and let's put a colon here so it doesn't look so wanky, and maybe a space. The space might be too much, but essentially we ask for a number greater than 0.0, and let's just add this please, just in case, like, because we're doing this kind of like, hey, enter it. But if you don't enter it right, please enter it again, a number greater than 0.0. Eventually, the user should get the idea that they should enter a number that's greater than 0 to get the number. And then, of course, we can do a system Oh, and let's just do this one. We want print. We don't want print line because we're going to be putting input over here. But so what we'll have is, let's do a new line. Let's inject a new line right here. So just in case they have to redo it again, it comes on a new line. And that'll be a lot better. And then what we'll do is we'll do a system.out print line of number at the end so that we know that they've properly validated or properly entered the number. We can do a print line, that'll work. And then we'll just do number. And maybe we can just inject, let's just leave it fine. That's fine. Because we're going to use this in our output or our input for entering currency to a file. So we're gonna do some file output here shortly. So let's go ahead and test this. I'm gonna set a breakpoint. If I can, why don't you like me? There we go. And let's go ahead and do the debug version. Okay, I do a step over. The first thing I do in my output, let's go ahead and look at our output. Let's do another step over. I ask for a number. So let's get our cursor there. There's our space that we wanted. So I'm going to enter in a negative 3.00. And then I'm going to do a step over because we've gotten the next float. We look at the while loop and hey, is number less than 0? Yes, it is. So that comes out as true and it runs and it asks for the number again. And there we go. And you notice I injected that backslash n in there, so we got a double hop there, which we could probably deal with later, but I'm fine with that. So now then we ask for another number, and I'm going to go up here and I'm going to do a 3.00, and then I'm going to do a new line, and that should come out as false. And we've successfully grabbed the $3. Now we should do printing that as currency. You know what? I'm not gonna go down the rabbit hole and do the formatting for that. You guys can deal with that. We may add to it when we get to the outputting as a file. So that kind of concludes our little, our bit of a talk on looping. Now what we're going to do is we're going to go into file output. And we're going to use this input method to continually output to a file until the user enters a -1 or a negative number, which means to stop entering in values to the file. And what we're going to do is it's a file that we're going to be putting money values in. And then we're going to write another bit of code that reads those values and adds them up together. And that will kind of cover our loops and our file access of the chapter. So I'm going to go ahead and stop the video. I'll resume it here in a little bit. We're going to take a bit of a break. Of course, you guys won't see it, but I'll be back soon. Okay, we're back. While I was gone, I did get the number formatting done for your $sign. I just added a $sign for the output for the line. That's added to a format method of 2 decimal points for the number that we're going to be outputting. Some of those, I believe we're going to be using Java util and Java text. One of those is used for the format or vice versa. Actually, you know what? Let's see if it dies on us. No, okay. Evidently those aren't used for that. Okay. What we're going to do is let's go ahead and just test this one time so that you guys can kind of see. I just ran it, see kind of the whole thing, $3, and then it outputs $3. Evidently we don't need those guys. And here's the next step that we're going to do is we're going to create a class, and the class, let's just go ahead and put it in the chapter 5 package. So I'm going to go over here, I'm going to right click, and I'm going to say new Java class, and we're going to call this currency out. And so that class is what we're going to be using to We're going to invoke it, and then we're going to have the constructor do most of the work in that class for outputting to a file. I'm going to be using your file write demo.java example in your code listing of your chapter 5 to complete this class, and then we will use this input method, and we will have the user enter in dollar amounts that will be saved to the file until they put in a negative number, and then we will terminate outputting to the file. And then of course we're going to build another class to read that information in. So let's go ahead and add this class, and let me zoom in on it for you. We're going to have most of the work happen in the constructor of this class, and then we'll put some things that we're going to be using. Let's say that we're going to use, let's make this private. Let's go with doubles for currency, because that's actually the standard. Floats are too small, because it actually should, for currency, it should be a long double if you're building a banking system, because you could have a billionaire, somewhere in your bank accounts. So let's go ahead and create this, and let's call this balance, or let's call this let's just call it currency, I guess. If that's, I don't think that's a keyword. I think we can get away with that. We'll see. If it dies, it dies. And then let's go ahead and add the constructor that's going to do most of the work. And that's going to be public currency out. And let's put our scope in. And I may have to look at our chapter 2 stuff to look and see if I'm messing up anything on this guy, because I'm getting a warning, but it may be nothing, but it could be something.
Playing from R2.
Oh, okay, there she is. Public currency out. Let's look at, I think, our chapter 3 examples where we did an object. And where was it? It was chapter 3 and rectangle.java. Let's bring that up. Oh, I forgot the parentheses, of course. Hey, it's those little things. It's always those little things. Okay, now let's go back here to currency out. Put in our parentheses. Yeah, okay. And I think we have our constructor. Now this is when we invoke this class, what it's going to do is it's going to ask for information. But one of the things that we need is we need the IO. We need to import Java IO for input output. And then of course the scanner utility. And so let's go ahead and close some of this hoo-ha that we got up here. Let's leave the rectangle in case I got to refer to it again. And the start page we don't need. Let's go back here to, why are you doing this? Oh, there we go. All right. It's going to be the scanner we need. We need the scanner code. And we're going to come back and get that loop, that do loop in there. So let's go ahead and put our scanner code in, and then we're going to need another library for input output, because we're going to be using what I call a file pointer, which is it's a file pointer you can think of as like your pen on paper. When you're writing to the file, it moves, your pen moves for how many characters you're outputting the file, and then when you continue to do output, the pen continues to move and keeping the position in the file that it was at before. So literally a file pointer, the file is the file pointer is your pen, the file is your paper, the file pointer is what you use to write on that paper. So this is going to be your Java IO for our file pointer, and let's just grab everything, an asterisk, everything in that library, I think, and I just need my semicolon. And we are good. We're ready to start some code. I think that's good. So now one of the main things that we're going to do is let's go steal the code that we've already got written over here, because we already got the scanner in. We're going to move some of this around though, So I'm going to take it and put it in. The main thing that we need is we don't need this anymore. Float number goes away. We need the scanner. That's going to be our first thing. That's for our input. And then what we need is we need our file pointer instantiation. And so that I'm going to get from the file write demo example. And it looks like the instantiation, print writer. Okay, so here's the file pointer. It's going to be with the print writer object that comes from your system IO or your IO file or library. And of that class, we're going to instantiate the actual file pointer, and that we're going to say output file. So that term output file, that's our file pointer. That's your pen on the paper, and the library it comes from is the print writer library. And then we're going to instantiate it by saying is it equal to a new print writer. And this is where we put the file name. This is our paper. So we're going to say my money. And we're going to do, this is going to be a text file. So I think we need to append the .txt to it. I'm pretty sure. So let's just go ahead and do that. Now, the issue with this is you notice how I'm just saying the file and the file name, but I'm not telling it where in the directory structure to put that file. And this is very important that you know with implicit file directions or direction is whenever you do not put the directory of where the file is located, like we could do something like C:\\/ and we have to use 2 backslashes because it's a formatter, so we're saying we really mean a backslash here. And so then it would put it on the C backslash, but we don't want to do that. In fact, you should not be doing things this way. You always want to use implicit file opening unless you're going to offer a graphical user interface for somebody to choose the file, or you're going to add a default argument to the console program that allows you to send an argument of where the file is going to be located. So in this case, we are hard coding it in, and the goal here, or what actually ends up happening, is the file is placed within the runtime directory of the program. So sometimes if we're running the program within the IDE, that directory will somewhere else. But if you run the Java program from a specific directory, that file will go in that directory where you're running the file from. So it's always saving, whenever you use that implicit file direction, the file always goes or comes from the directory of where your program is running from or where it's in. And I believe, when you start this in command line with the .java, that would be the directory that you have the Java file in. So it's going to look a little bit different here because we're working within the IDE, so it'll be somewhere in our folders, and we'll figure that out when we get it output, and then we'll look at where it's where it's placed. So now we're going to go ahead and we've got our file created with our file pointer, and now we use the file pointer to output information to the file, and it works just like your print. It works just like that, and so it's going to happen in here. And essentially what we're going to do is we're going to get the currency value that we have in our object, and let's change this to next double because we changed that to a double. And then we're going to say while that currency value, and we may need to change that because that might be a keyword. I don't really like that. Let's just put an M in front of it for my currency. Oh, you know what? It's not changing color, so yeah, okay, let's keep it. That's what namespaces and packages are for, is to protect our variables. And then what we're going to do is, instead of doing an output using system.out print line, this output then goes to the file. And this will be the currency. And we have our format, but this, instead of going to system out, we're going to use our file pointer for that. That's going to be our output file. And this is pretty much the way all languages work. Oh, output file. For text input and output. I believe, good. Now here's the thing, is this opens the file, and it looks like we do have an error there that we'll have to play with and look at. I may have to pause this and come back because of that, but we'll see. Yeah, actually, what is that error? Oh. Yeah. We should do a try catch here. That's a big baddie. So essentially, we do a try catch in case the file can't be found. It looks like, so this try catch, what it does is it says, hey, try to create the file. Try to create the file. Now here's what can happen is if the file is not able to be created, it catches the error that's thrown within the print writer code, and then what we can do is we can log what happened, why the error was thrown, and it looks like NetBeans automatically put that in for us. That's kind of cool, but and this is actually a necessary thing. You need to have these try catches. Because this is validation. You know, if you write crappy code, it's crappy code. So it's important that you make sure that the file was able to be created, because the file could not be created because maybe, hey, you're working within a directory that needs special permissions. Maybe it needs you to be running that program in the administrator account because that directory only allows the administrator write access to that directory. Or it could be something as simple as there's no more space on the disk drive. So that's kind of your due diligence. So now then we have another error here. I think that one can be ignored for now, because we want to move this. We don't want this working with the output unless the file was actually successfully opened. So that's got to be in the try right here, because the catch is designed to catch it. You know, hey, the plane is broken, it's going to crash. We can only open the file and work with the file if we successfully opened the file. If there was not an error thrown within the print writer object that says, hey, we couldn't open this file. We couldn't create the file. So that is a modification that we need to add. Then we can ask for the number. And then we can output the number appropriately to the file because the file has been successfully opened. Okay. I just had to close the browser because it's making noise. Then if we have an error, it'll log it in the output or the console. And we can have our own message here, but it looks like it auto puts something in for us, which is fine. So this is the actual code. Open the file, output to the file, and here's the thing that you must never forget. You must close the file. If you don't close the file, it's hosed. Once you open it in a scope and you don't close it in that scope, that file is trashed. You got to recreate the file. So usually when I open up the file, I immediately close it, which makes it so that we don't make that mistake. All right, so this is really close to what we had before. The only difference is the data that we output is instead of going to the screen, it's going to the file. That's it. That's the only difference. And then, of course, we open the file too. And we are allowed to enter numbers until until the numbers are incorrect. Here's the thing is this will actually look, and until currency is less than 0, then it comes out. So we actually want to be printing the information inside of that loop, because I want it to allow, this isn't really input validation, it's more of a loop to continue outputting information to the file until the user no longer wants to enter information into the file. And that's when they enter in a negative number, and it's done, and it runs, and the file closes. So that's where the next change that we're going to have. Okay, we are actually ready to test this. I'm not going to test this in debug mode. You guys are savvy enough to where you can do that. I'm going to go ahead and run this just as it is, and then we're going to go poke around and try to find the file. So, and then of course, yes, we're going to have another break. I probably need another break before we get on to opening the file to process it. But let's see how well this goes. We're going to run it. It may just be a total nightmare, but hey, enter a number. I'm going to put in $3. Okay, so it did hose. Enter a number greater than $3. So it looks like we need to look at this currency, this while currency, and why is it not asking for the next number? So I think we need to change this to while currency is greater than 0, and it will continue to enter in a number because we were using it to drop out as long as currency was not less than 0. So we just need to flop our logic there to continue out with it. But we did open the file, we did save it, and it closed. So let's go poke around. Well, no, let's just run it over. If we run it over again, it's going to overwrite the file automatically. That's the way all print writers or file pointer objects work. So we'll just overwrite the file that is currently there. And let's run it differently now so that we can put in more than one number. There. Oh my goodness, epic fail. You know what, guys? I'm going to have to pause this so that I can figure this thing out, and then we can continue on. I want this loop to continue accepting numbers until we put a negative number in, and then we're done. I think that I need to get in and debug it on my own, so I'm not kind of taking up time messing around with it and your time, essentially. So I will be back. Okay, that was a simple one. I got really silly and kind of, yeah, I had a dumb moment. Yeah, we're actually running the code that's in main, and I didn't run any of the object code. I got it all written and like, okay, so simple fix. Let's go out here to our chapter 5, because we're using this object to do everything for us. Chapter 5 is opened up here. Yeah, it's just running this, and we don't want it to run this. We want it to do the object. So let's just get rid of that. It was doing exactly what I told it to, as usual. What we want is we want to instantiate a currency out object. Because I was wondering why the debugger is not actually working here, and it's because I've never instantiated the currency out object. So it never ran. So currency out, my_c equals new currency out, and this will invoke the constructor, which will then run our program. So now when I do my debug here, which is why I should have probably said when I said I'm not going to do the debugger, I'm just going to run it. Epic fail right off the bat. That's why you should always debug, because then you realize those silly things that you do, and you save time essentially. Okay, so this instantiation from the main should implement the constructor, which then will run and give us our stuff. And of course, yes, it does. It gets in, opens up the file pointer, asks for the next double, and then we go to our output, and there it is. And you know what I'm going to do is I'm going to just remove this And I'm going to hit probably continue and just restart this without the debugger. And let's do $3. Okay, then it goes for another one. Okay, $4, $6.23. And then let's just do a -1 here so that we can come out. And we're done. Okay, so we entered in 3 numbers to the file. So let's go look into our project and see where the working directory of us running it in debug mode was placed. And I believe I'll put this on my desktop. Chapter 5, it's right here. That's why I always tell you, put it on your desktop. Don't hide it from yourselves. Okay, now let's see. There it is. So the working directory was in the Chapter 5 project directory. That's pretty good. I like that. It didn't put it in with the .java. But we open up that file and you see there's, oh, we got a bug, -1. That's going to cause a problem. We actually don't want that in the file. And so I think what we can do is just do a quick check on it and only output. Let's just throw a quick if on it so that doesn't happen, and then we'll run it again and make sure it's fixed. And then we'll take the much needed break and of course come back with reading in the file. So let's go ahead and go back to here. Here's where our problem would be. I should not be outputting unless the currency, so I'm going to just do a quick if statement. If currency is greater than 0.0. And it will only allow, and I don't need to put my little squigglies in there because the if statement is just a one-liner. So this one-liner is the only thing that's in the scope of that if statement. Let's tab it in so that we know it's in that scope. So I don't need to put those squigglies in there, which is fine. So now let's go ahead and run it again, and let's just do a quick regular play on it, and let's bring it up. Okay, come on, do your thing. All right, here we go. 434, 823, 2, whatever. I'm just putting gobbledygook in here. 120 and 450. Okay, and then now we're going to do our -1. Okay, then we're done. All right, now let's go look at our file. Whoop, whoop. Okay. And, you know, the only thing that I don't like... Oh, no, it's good. It terminates right there. That's perfect. Okay, so what we can do now is we can use create another file in pointer, a file input object that reads by line. So it's going to be a do, or it's going to be a while... Now we can convert this to a for loop that outputs, and I was telling you that we're going to go with a for loop. We might have to cover for loops later because this is just straight up with while loops, and I made it so that it. No, let's cover for loops right now. Okay, for loops are different than this while because let's say that we wanted to have this constraint. So what I could do is I could do a for loop, and here's the first part of a loop, because we're talking about the 3 parts of a loop, and we usually call it I, and that's our iterator, and then so we start our counter at I is equal to 0. Notice the semicolon there for the syntax. Then here is my my checker, my relational expression. While I is less than 5, then we say I++. That's our update. So essentially it's like a while loop, but it's all in one line. And that's the main thing about a for loop. Now this is the loop that you should use almost always. If you know how many things are going to happen, or what the count of something is, how many times you need to repeat, you should always be using a for loop. If you have no known stopping point, then that's when you use a while or a do while. And so this for loop will continue to run and update within its scope which I'm going to put here 5 times. Let's make it simpler. Let's make it 3. And let's set our breakpoint and hit stop here. And let's go ahead and run this. Okay, and okay, I'm going to do a step over. We print, enter a number. So I'm going to go to output. Oh, I got to do a step over again. It didn't come. Okay, there's our print. Then we're going to say currency is equal to next double. This is where I'm going to put $3.03. Then I hit enter. We do another step over. It goes to the next line. Is it greater than 0? Yes. Output to the file. Start over again. I now becomes 1. I is now 1. Because we started our repetition again. If we look at our variables, we see here our locals. I has the value 0. We do a step over. I now has the value 1. We now are continuing with our repetition where I is now 1. And then we output our stuff, get our input. Let's do 2.23. Step over. It outputs the file, comes back. We go one more time. Now I is 2. Now I is 2. Okay, then we output for our input again. And we put in our next double. Now this is where it's going to terminate. So it's not like that do while where we're waiting. We know exactly how many times we want this to run. So we don't have to do that negative number termination. Okay, now we have, is it currency greater than 0? It is. And hence this is going to be where we don't really need this if statement anymore. Unless they, enter in something that's not a negative. And then we close the file and we're done. And the program is successful. We go back here to our directory, and we will see that chapter 5, my money, has 3 items in it as stated for the loop. So yeah, it just puts all the while loop stuff together in one. And now we have gotten to the point. Let's go ahead and do this. And there's a reason why I say Control Z is a programmer's best friend. It's a really quick undo. So I'm just going to lay on the Control Z so we can go back to the way the while does things. And then let's rerun this real quick without debugging. And let's get in like 5 numbers, 5 good numbers into our let's go with $35. Why not? 123 point blah 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 dollars. Okay, and let's make another one. Let's make this one really big. Okay, and then let's do another one. 8. And then here, let's do our -1. We are done. We got 5 numbers. Let's go back and look at our file. Okay, we got numbers that we can add up. So it's break time for me. When I come back, we are going to write a whole nother object. And we are going, when we instantiate it, its job is going to be to read the file, print the items in the file, and the total of those items that are in the file. It's going to add them up. Now that might be a journey because we might be doing some text to doubles. So we got to go from ASCII code to numerical values. That may be part of it. I'm pretty sure Java has a way to implicitly handle that issue of converting from ASCII characters to actual numbers that we can process. Because when that information goes to the file, it's converted from a number in a numerical value that is an 8-byte double to just the ASCII characters that you see in the file, and each character is just 1 byte. So when this is output, this currency is output to the file here. It does a conversion routine where it goes from an actual double value to a sequence of ASCII characters that are put on the file. So you're actually not outputting the number to file. You're outputting the representation of the number in its ASCII code equivalent. And I'm pretty sure we talked about ASCII code. If not, look it up. It's ASCII, ASCII code. This is a kind of an important aspect of programming. ASCII code is important. It's on every system, no matter what. Look into what ASCII code is and learn about it. It's very pivotal to your understanding of programming. Okay, I'm going to come back, and yes, I was probably correct. It is going to be an hour and a half video. We got another half hour of reading that information in, and then printing the total. Okay, thank you. All right, we're back. Let's go ahead and start on reading in data. And fortunately, what's nice about outputting and reading in data is much of the code that you have for outputting the data is pretty close to the same as inputting the data. So what we're going to do is we're going to go ahead and add a new class here to our project. Let me minimize some of this stuff. Okay, so I'm going to go to our package and create a new Java class. And this one's going to be called currency in. And it's going to be pretty close to the same stuff. So we're going to be able to just go over to the currency out and copy paste. And we're going to need our currency, of course. Our currency double or variable. Then we're going to need everything that's in the constructor. And let's just copy the whole thing. And what we'll do is we'll change everything as we go for the input. So yeah, very much the same. Oh, why did he? Okay, well, yeah, okay. It doesn't have. I don't have. Well. Oh, cool. It put it in for me. You know what? That's kind of nice. Okay, we got to rename this currency in. And put in the logger stuff for me. I think we probably need that. Oh yeah, I put it in for me again too. But let's do all the I/O instead of piecemeal. So what I'll do up here is I'll just do I/O star here, which means all libraries in the I/O imports. Okay, so we've copied in the output. Here's the first thing that we need, the scanner for the keyboard. We probably won't have input for the keyboard on this, so I don't see that we need that. It's just going to go in and read the file. Now this one right here needs to be changed. So I'm using your, let's see the file read demo, and we're going to be using an input file. An input file instantiation. Let me see. Interesting. They use just a file instantiation for this one. Okay. All right. Let's instantiate the file using the file object. And this is going to be the input file. And we are going to say it's a new input or new file, and it's got to be capital F. And then what we're going to do is we're going to use the literal of the file opening scheme, and since of course we're not telling it where to go, it's going to just put the path of the working directory in it. And then I think this should be in the try catch. Actually, we can get rid of that. This should be in the try catch to see if the file actually works or is able to be opened. And then right here, let's rename this, and we're going to say input file close. Now another thing that we're going to do is just to get rid of all this, and we're going to replace this with a while. And so this will be just an empty while for now. we're going to go ahead and put our squigglies in, our scope. And the goal is for us to open the file, which we have done. And then we're going to say while we're able to get information from the file. And so what we use is the file pointer, and then they have a special function called has next. So with every file that we have, and for instance, this file that we're working with in our chapter 5, file, and every file that we have formatters here. We got new line characters. You can't see them, but a \n is at the end of each of these guys, a \n. But the text editor doesn't show it. And then another thing at the very end of this is at the end of the file, there's an end of file character. That's all part of the ASCII code. So you can't see that in the text editor, but the text editor knows when to stop displaying information in the file when it gets to the end of file. So the mechanism that we're going to be using is while we're getting data from the file and there's a next item in the file to get. The other mechanism you can use is you can say while we have not reached the end of the file character. And there's, different languages have different means of implementing the same kind of idea. We want to read the file until we get to the end of the file. So let's go ahead and try this code out from your example of your book. And we're going to use the file pointer, and we're going to say while we're able, or we have a next item to grab in the file. So essentially it's kind of like while we are not at the end of the file. And so this should is the operative word. This should read until the end of the file. So let's see, we may have some issues with that. I think it's starting to have just automatically right now. But what we can do is we can create a string and use the file pointer's next line function to be able to handle that. But I'm just kind of wondering what is this guy? So it doesn't like the has next. Did I spell input file right? Yeah. Okay. Well, it's right from the book. Let's see. Well, and then this guy doesn't like us either. I'm wondering if there's an issue with this guy because input file input file equals new file. You know what? Let's move on, and we may need to come back and fix those. We'll see. It does not like them, but we can play with it here a little bit. Let's see if IntelliSense will actually help us out a little bit. Yeah, because the input file does not have a close. Well, that's interesting. All right. I think I am going to go ahead and pause. We're already at a pause point. Let's go ahead and just kind of take a look at the whole picture. Essentially, I've just created another object for inputting information from the file. And the constructor is going to open the file to read information in. And then we're going to have code that goes until the end of the file, read the information in, and print it. That's going to be the first thing that we're going to be doing. But evidently I have a few little persnickety issues that I'm going to play with, and I'm not going to take your time for that. I'm going to go ahead and look off to the side here for a second and come back. Okay, yeah, I figured out what the silly mistake was. So the file is, the file pointer that we're going to be using a scanner object to do this. So let's just call this lowercase file. And then we have to create a scanner to input from that file. And, input and output are pretty much the same whether they're going from the console or to a file. Those things, that code can be very, very much the same for all languages. So we're going to call this one input file. And we're going to use the scanner to walk the file. So the scanner is going to be our file pointer in this case. So now we're going to say new scanner, but what we're going to use for the input is not the system in the keyboard input. We're going to use the file for the input, and that's where I goobered. So now we have the scanner that's going to be used as the file pointer. It's going to go through the file, and then we're going to have this while loop for the file pointer that always looks at the next one, has next. And as long as there's as long as there's a next one, the while loop will continue to look. And now we can close the file with the file pointer, I believe. Oh no, we just yeah, we actually do it with the file pointer. That's interesting. Okay, okay, that works. Java has a different way of doing things. Okay, there we go. So we close the file pointer, open the file pointer for the file, and now what we're going to do is read in the information now. And we're going to create, we're going to use currency, and we're going to add another variable up here. And this is going to be called total. Now, the next thing we're going to do is, I believe, we don't need to do the conversion from ASCII, the ASCII characters, to an actual number, because the scanner object does that for us. That's kind of cool. And so what we can do is we can just do a simple thing is currency equals the file pointer dot next double. So it'll read the first one into currency. Then what we can do is we can do something like this. Let's do a quick printout. Print line. And we're going to say file opened, and that does a new line, so we don't have to do anything more. Then we're going to do system.out.print, capital S, system.out.print line, and what we're going to print is currency. But we want to do that formatted, so let's go steal some code from over yonder. I think we can do it this way right here. Okay, and let's just go ahead and put this guy in there. And this is going to be just system. Oh, you know what? We may have a problem with this because we put the $sign in the file. That could be a big problem. We may have to regenerate the file without the $sign. We might have to get rid of this, because if we have the $sign in the file, it's gonna have a problem. I don't think Java is going to be able to handle it. It's probably going to break. But that's okay. We'll go back and regenerate the file without the $sign, and Then when we load it up, we'll put the $sign in it. So we actually don't need this guy. It can go away. So we output the currency. Now here's where we do our total. We're going to say total is equal to total plus the currency. So this is an accumulator, and we need to assign total up here equal to 0.0, so that it begins at 0. And so the first time it'll say total is equal to 0 plus the first one that we read in. And then total will be equal to that. Then we take the previous value total, add it to the next one the next time this loop runs for the next number that we read in. And when this is done, then we want to output the total. And we will put total here. And then what we'll do is we'll say total with the $sign and a space. Format it, and then the total will come out with 2 decimal points with that $sign. So again, we're most likely going to have to regenerate the file without the $signs. Because I think this is going to totally break. Okay, so we have a file. We open the file. We read in the next double, and while there is something to read, we continue to read. As soon as there's nothing else to read, or we've reached the end of file, that's when we bounce out, and then we output the total of all the currency that's in the file, and then we close the file. Okay, so let's breakage begin, and what I'm talking about is if we look into the mymoney.txt, we put the $sign in front. So when we read it in with the next double of the file pointer, the scanner, it's going to have a problem with that. I guarantee you it's going to break. Yeah, it's going to break. So let's go ahead and what we'll do is let's fix that first. Let's go to currency out. We don't want to do out file print line. We do not want the $sign there. That's what we want to take out. So this is our currency out. Let's just put regular dollars in there, our regular numbers in there without that $sign. And when we print it, and that's fine. When we print it to the user, that's when we'll put the $sign in. So we're going to rerun this with just the instantiation of the currency out. And then we're going to check the file. Then we can test the file input. So I'm just going to put some stuff in here, and well, I think I got 2 of those. Okay, now we're going to do my -1 to quit. Okay, now the program's done. Let's go look at the file. Okay, we got our numbers without the $sign. Now, we are no longer going to test this. We don't need to. Let's just comment it out. Now what we want is we want to test the currency in. So we're going to do a currency in instantiation. Okay, did I call it currency in? Should be good. And it's a package, so I don't see that I needed to import it. Why doesn't it not like that? Currency in. Okay, maybe I just mistyped it. Oh, I got an equal sign there. That's definitely going to cause a problem. There we go. Okay, let's no, I don't want to remove it. Sometimes it is helpful, sometimes it's not. Okay, let's go over here to the currency in object. And let's set a breakpoint right here just to make sure everything's kind of working right. And I'm going to go into debug mode. It's going to instantiate the object and run the constructor. Okay. Okay, let's go look at variables. I'm going to remove this. Delete. 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 That way I can just kind of look at this, which is the object we're currently in. Here's our currency. Here's our total. I'm going to step over. I can add a watch on that file and make sure it was instantiated correctly. And I'm going to go over here and say add watch, new watch, and it'll show me what's inside a file. I could break it down and look at everything in file also, which is, you know, beneficial. And then we got our file pointer, which is the scanner. And then we output, so we output that the file's opened. Okay. And then we say, okay, while input file has next. Okay, so when a file is opened, the file pointer, where the file pointer is at, always starts at the beginning of the file. So let's visualize that a little bit with our file. And you can kind of think of the, when you're reading information in from the file, it's like your eyes reading a book. You always start at the top left and you read from left to right down. So the file pointer starts here and reads that first number. Then it will continue on from its last point for every, every read or any kind of read operation of that file. And it continues on down just like your eyes in a book, reading information or data. So when we open the file with the file pointer, that file pointer always begins at the very beginning of the file, then reads in the data, and then it'll read in the next piece of data through the loop the next time, and so forth. So every time that loop runs, it's moving that file pointer by one double value in the file. All right, let's go back to NetBeans. So while it has next, we can even add a breakpoint there. Not a breakpoint, but a watch there, new watch, and we can keep an eye on, hey, okay, so it says true. So we opened the file, it's at the beginning of the file. The next value in the file is there. We read in the first double. So we look at the currency. Currency reads in 3.45. Oh, happy dance, it got it. Okay, nice. And then we print to the user the currency that we saw. So let's look at our output. There it is, 3.45 with our dollar sign. Nice. Okay, so it's working. And then we have another next one. We read in the next one. That's 23 output. And you see the total is counting up all this time. It's accumulating. So total is now 26.90, and then we're going to have 65.34 added to that. And then total is going to be a big number now. It's going to go up to 92.24 while has next, and then continues on until, let's see, where are we at? Currency is equal to 76.58. What is the last one in the file? 76.58. So it should stop after this. Okay, this is where it should stop. Boom, it stops. Then we have our total. It's going to output our total. Then it's going to close the file. So let's look at our output. Whoop, whoop, we got it. Okay, so hopefully through this discussion, you kind of get an idea of how loops work and how, at least a rudimentary beginning understanding of how to read information to and from a file, how it behaves whenever you do a read operation, how the file pointer moves along, how the file pointer is like your pen and when you're writing, like your eyes of reading a book. When you're reading information, it moves along and always stays in the place that it's at until the next read operation. Then it moves along after that. And through this while loop, we're reading in just one double number. So every time this while loop runs, we're reading in this one number and reads that in. Now the file pointer is here. It reads that in, while loop runs again. Now the file pointer's here. Reads that in, file pointer goes here. We read it, do another read, and the file pointer goes here. And that's how file input and output operations behave. And it kind of makes sense. It should kind of work that way. So we are at the end of our journey on chapter 5, guys. Yeah, remember, while loops are only for when you don't know how long you're going to be looping for. Always use a for loop unless you absolutely have to use a while loop. Data validation, you use a while loop because you don't know how many times the user is going to screw up. Yeah, always use a for loop. Otherwise, all right, because it contains all the 3 characteristics: your starting value, your update, and then your relational expression. And remember, 0 is 1, and 1 is 0 in programming. So just think in that way. Do not start loops at 1. Do not ever start loops at 1. Start them at 0. Get in that habit. It is an accepted habit. Also, when you create loops, for loops, use I and J. That's another thing that's common. And so some of those standards are just part of working in the profession. All right, guys. Thank you very much. Bye.